Yes, dear viewers, Teacher Ambrose, as usual, Riverflow International. Now, I want us to share something about electric bell. Electric bell uses the principle of electromagnet. We all know electromagnet, it becomes magnetic once electric current passes through electromagnet or passes through the coil. When the coil gets the flow of current, it magnetizes the soft iron bar, whereby after becoming magnetic, it pulls the soft iron bar and the hammer hits the gong, then gong produces the sound. The most part we talk about gong, the hammer, the soft iron bar, and sometimes it is hard for learners to understand. I want us to deep dive into how electric bell works, the parts, the functions, and probably how it produces a sound to help our learners learn practically and help our learners be the ones carrying out the activity hands on for their future use. Let's go together. So, as I have said, this is our electric bell, and we'll begin with, we have to make sure it has the source of power, and in this case, I am going to use the dry cells. This electric bell of mine uses 3 dry cells, and the 3 dry cells are arranged in a series way, or they are cell arrangement. It is positive, negative, positive, negative. That's why we call a series arrangement. So this is the source of power, or what we have called the dry cells. And in electric bell, we have this part, and this part is what we call a switch. From where we are, electric circuit, electric bell, wherever we see a switch, the use of the switch is to break, complete the circuit when there is a need. This is the reason we have the switch. We have here what we call the contact screw. This contact screw, you see the wires are connected to the contact screw such that they can allow the flow of electrons or the flow of current up to the soft iron bar. This is a coil I have been talking about, or I have called electromagnet, that gets magnetized and pulls the soft iron bar to come and attach, because this soft iron bar is a magnetic material. Obviously, we have the hammer, as you can see, and it is this hammer that hits the gong and produces the sound. So, in this case, the part that produces sound in electric bell is what we call the gong. Let us try to carry it out and see really what we have talked about. Is it true? Does it work? So, to begin with, after we have arranged our dry cells, now you come to the switch. So, once you press the switch, you can see the buzzing. You can see the buzzing whereby the hammer is hitting on the gong. And once the hammer hits the gong, surely the gong produces the sound. Someone can ask you, which part of electric bell that produces sound? And that part is what we call the gong. Then which part of the electric bell that hits the gong such that it can produce the sound? Surely it's this part we have called the hammer. Then this is a coil that makes what we call electromagnet. And surely, as I have said, the switch breaks and completes the circuit. You can see after I have released the switch, then the current flow has been broken down, and so there's no more flow of electrons, and electric bell will have to stop. That's how electric bell works. And surely, if we could do this one with our learners, then they can get the idea and the concept of how electric bells work. Thank you so much, Teacher Ambrose.